is also called as one is also called as one is simple primary key. Okay, is also called as a simple primary key. Otherwise, is also called as a candidate key. Candidate key. Otherwise, is also called as a super key. Every primary key column is called as a simple primary key or candidate key or super key, and also we can say what is now composite primary key. What composite primary? So these all names are belongs to primary key only. So the primary key in different manner, the different names we can call. But when we called a simple, when we called a candidate, when we called a super, and when we called a composite, means a simple pointer. Blindly remember, when a primary key is applied, a primary key is applied on a single column, on a single column, that every single column of primary key we called a simple primary key, or we called a candidate key. Okay, and we called as even though super key. Okay, simple primary key we called as a candidate key, and we called as a super key, right? Now, so when we applied primary key is applied on multiple columns combination. When you apply multiple columns combination, then we called as a composite, then we called as a composite primary key, or else then we called as a super key. Okay, now so that means, now what is the conclusion here? Every primary key column is called as a simple, candidate, and super. And when you apply your primary key on multiple columns, we can call it as composite or super, because super key means either single column or combination of columns. Okay, now so this is the definitions of super and candidate. And finally, what you understand here, all our meaning is primary key only. This all our meaning is primary key only, but different ways we can call. That means primary key is also called as a candidate key. Primary key is also called as a super key. Primary key is also called as a composite primary key. But when we call as means based on the primary key on which columns, how many columns you applied, based on that it will be decided either super or candidate or simple or composite. Okay, now but finally anything what finally all are same meaning of primary key. Okay, now right, now let you come out, let you come out and see our voice code normal form. Let you come out voice code normal form. So voice code normal form, what it was telling here, observe. So this is over now third now. As again, any dependency A to B, A should be primary key. Okay, so let you see what it means. For example, guys, here college enrollment table is there. College enrollment table is there. Okay, now so in this college enrollment table, student ID, subject, and professor is there. But here, student ID, subject, these are composite primary key columns, these two. So these two are composite primary key column. Okay, no? These two are composite primary key column. Okay, now you can see in this, okay, we know professor column is a non-primary key, non-primary key. Okay, so but professor is not depends on student. Professor is depending on what? No, subject. Professor depends on subject, but whenever professor column is depending on subject, then professor column should be super key. Yes or no? But here what happened? Professor column is not a super key. Professor column is not a super key. Why? Because we are not applying any primary key on this. Okay, but professor depends on subject. Subject is a super key, but not a professor. But as per the boys code normal form, what it was telling, suppose are you, that means a column is going to be depends on, okay, any other column. That means for any dependency, A depends on B, okay, then A should be super key. So here professor depends on subject. It means that professor should be super key, right? But unfortunately in my table, professor is a non-primary key column. Okay, now, so that means this table is not satisfied your boys code normalization technique. Okay, boys code normalization technique is not satisfied. Then what we want to do, let you see. Let you see here, I'm saying. In the above table, student ID subject from primary key columns, which means that subject column is a prime attribute. Okay, now, but one more dependency was there. Professor depends on subject. Professor depends on subject, and while subject is a primary and professor is a non-primary key. So that means which is not allowed BC enough. Which is not allowed BC enough. Which is not allowed BC enough. So now how to satisfy this BC enough means, now let you come out and see. So one more table I designed here, student table. In student table, student ID and professor ID, these are the two columns I was taken. So many columns. Okay. Now, next come to college. Okay, professor table. Another table I was taking, professor table. In professor table, professor ID and professor, these are composite primary keys, and the subject is a non-primary key attribute. So now what happened? Professor depends on subject. Professor depends on subject, and now professor is a primary key. That means professor is now super key. So professor depends on subject and professor is a super key. It means primary key. So now this table is satisfied your boys code normalization form. Okay, now so now your table is satisfied your boys code normalization form. Okay, now so this is BCNF we call as. This is BC enough we called as. Okay, right. In the next technique, the fourth normal form. The fourth normal form. Okay, now. So first of all, read these 2 points, guys. Read these 2 points first of all. Okay, right. Understand? Now you can see. So boys code normal, fourth normal form, right? Now, so basically, guys, here fourth normal and the fifth normal forms are these two techniques are called as optional techniques. We called. That means for every time we can't use this four enough and fifth enough, and these are the that much not important in your table. Okay, but first enough, second enough, third enough, BC. Up to these four techniques are very important. But this last four and fifth techniques are not that much important role, but it is just optional. So very rare cases the people are using these two techniques in their database designing part. Okay, so whatever it is, but let we see what is fifth, fourth normal form, what is fourth normal form, and what is fifth normal form. Let you see guys here. Okay, right. So now a table should be satisfied fourth normal form. It should satisfy the following two conditions. One is your table should have a voice code normal form. Okay. And the second one is very important. Observe. A table does not contain, more than one independent multi-valued attributes. Okay, it's nothing but multi-valued dependency. Okay, so a table does not contain more than one independent multi-valued attribute. Okay, now understand now? So it means what it was telling us, suppose your table is having more than one independent multi-valued column. Okay, more than one independent multi-valued column is there in your table, then immediately those columns identify and remove. Okay, identify and remove means separately have to do it. Okay, so when your table is having more than one independent multi-valued columns in a table, okay, more than one independent multi-valued columns in a table, then immediately those columns will be separated. Okay, that's when you separating, then the multi-value dependency problem is overcome. If you're not separated, then it was having this problem. Okay, so now the question is, what is multi-value dependency, sir? What is multi-value dependency, sir? Means, observe. So this is very important to read. In a table, so definitions are very very important guys here, maximum understand definitions. In a table, one column same value. In a table, one column same value. See, very important. In a table means a table. In a table, one column, one specific column, same value, match with match with multiple values of another column is called as multi-value dependency. Okay now, so definition what now? In a table, one column same value, match with the multiple values of another column. Okay now, so what it means, sir? Means, just observe example. Can you see college enrollment table? Can you see college enrollment table? Right? In this college enrollment table, we have a student ID, course is one more column, hobby is a one more column, right? Now you can see, so in this table, can you observe a column, one column, a column or a one column, same value means one, same value matching with the multiple values of another column. So one Oracle, one Java, one C Sharp.net, one PHP. Okay, now, so having guys here, so multi-value definition, understand now all of you. Okay, what is the multi-value definition? Okay, a column, same value, a column, same value. Okay, matching with the, okay, matching with the multiple values of another column. Definition understand now? So one. This is only same value. The same value comparing with the, or match with what now? Multiple values. Multiple values means are Oracle, Java, C Sharp.net, PHP. These are called a multiple. Okay now. So now this kind of situation is called as a multi-value dependency. Now tell me guys, So your definition, all of you clear? Now your definition, all of you clear, guys? So multi-value dependency. This definition now understand, all of you clear it? Okay, now, right? So now the definition understand, all of you, right? So now this is what the definition, guys, here. Now you can see. Now you can see. So that is what the definition of multi-value. But your table want to satisfy your fourth normalization technique or fourth normalization form. What I said, a table does not contain more than one independent multi-valued column. Attribute is nothing but column. But can you see, guys, here, can you see in your college enrollment table, three columns are there. In out of three columns, one is a student ID, course, and a hobby, right? But can you tell me, guys, here, course column and hobby column, these two columns are any dependency was there here? That means course column is depending on hobby and hobby column is depending on course. Is there any relation in between course and hobby? Come on, guys. Okay, no relation. So no relation, course is not having any relation with hobby, hobby is not having any relation with course, and two different independent columns, two different independent columns. Okay, so that means your college enrollment table, your college enrollment table is having more than one independent multi-valued column. Okay, your table is having more than one independent multi-valued columns are there. So that's why this table is not satisfied your fourth enough. Okay, that's why this table is not satisfied your fourth enough. That means the fourth normalization technique is not satisfied. So that then how it will be going to do means, let you see. So you're carefully observe, here. So in the above table, there is no relationship between the columns course and hobby, right? So they are independent of each other. They are independent of each other. So there is no so there is a sorry so there is a multi-value dependency was there, which leads unnecessary repetition of data. Okay, now so now we can see. So what we want to do, suppose your table is having more than one independent multi-valued columns are there, then what we want to do, first identify, independent multi-valued attributes, that is columns. First identify independent multi-valued attributes, that is columns. After identify those columns or attributes move into separate tables, and these tables are called as a for enough. These tables are called as a for enough. Okay, now so what I want to do, first in my table, is there any independent multi-valued columns are there or not there? First identify. Okay, more than one. If more than one is there, problem is occurred. More than one is not there, no problem. So more than one independent multi-valued columns are there in your table, then immediately identify those columns and move into separated tables. Okay, so when you move into separated tables, after moving into separated tables, those separated tables whatever it was there, those are called as a fourth enough. Okay, so now here I was identified, what I was identified here, course and hobby. So in this table we have a course and a hobby. Okay, now in this table we have a course and hobby. These are the two, okay, independent multi-valued columns are there. So now what I want to do, those two columns I have to separate now. So separating purpose, what I'm using guys here, let you see how to separate it here. So one table I separated with the hobbies table. In hobbies table I was taken student ID and hobby, and these both are composite primary keys. So one cricket and one hockey. Okay, this is one. Second table is called as a course opted table, and here also student ID course, and here I will take a composite primary key. Okay, now so one Oracle, one Java, one C Sharp.net. Okay, now so now what it was happening, you can see now. So now in course opted table and in hobbies table, in these two tables there is no more than one independent multi-valued columns. Understand now? In your hobbies table as well as your course table, there is no more than one independent multi-valued columns. Okay, so that's why these two tables are called as a four enough tables. Okay, now so that's why it is called as a four enough. That means the call is whatever the one table is there, in the table we have more than one independent column values. Those more than one independent multi-valued columns I need to separate it. So when you separatingly, okay, when you separated, then those separating tables are called as a for enough. Okay, those are called as a for enough. So what is 5NF? Now we can say what is 5NF. Now we can see what is 5NF means. Yes, the 5NF is nothing but it's a quite opposite guys here. The fifth NF formal is a quite opposite. What is a quite opposite here? Answer. If a table having multi-valued attributes, okay, now your table is having multi-valued attributes. your table is having. and 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 also and also the table cannot decompose into multiple tables. Okay. And also that table, so that table means in which table you have a more than one multi-valued attribute columns are there. So that table don't decompose means what now? Separate, divide, break, split is called as a decompose. So that was, you don't want to decompose. So without decomposing my table, whatever the multi-valued columns are there in the table, so that I want to keep as it is. So whenever you are keeping as it is without decomposing, then the table is called as a fifth enough. After decomposing, whatever the tables are there, those are called a four enough. So that means fifth enough is a quite opposite of a four enough. That's why simple, if you want to understand, simple understand, see, course opted table is a four enough table, and hobbies table is a four enough. So but before hobby and course, we have a one table that is called as a college enrollment. So can I say guys here, college enrollment is called as a fifth enough? Can I say, guys, come on, this table, can I say it is a fifth enough? Okay, right. So this is what. So when you are not decomposing, that means your table is having multi-valued columns. Okay. but it is not decomposed as it is this table you want to keep it, then it is called as a 5NF. Without decomposing as it is, if you keep it, then it is called as a 5NF. Suppose this table, when you go to decomposing into two tables or decomposing into separate tables like this, then these two are called as a 4NF. So when you decompose, is called as a 4NF. Without decomposing as it is, you are keeping that, then it is called as a 5NF. Okay, so that's why the fourth NF and fifth NF, these two options are two normal forms are very rare cases, because nothing was there in this. If you keep as it is, nothing problem, because it is a fifth NF satisfied. If you are decomposing, then it's satisfied fourth NF. So that means, it means what now? Either decompose or not a decompose, that is a user wish. That is a programmer or user wish. If they want to decompose, they can decompose, even though nothing problem. If you are not decomposing as it is, or you keeping your more than one multi-valued columns in a table, even though not problem. So that's why 4 and a fifth and of these two techniques are optional techniques. We call optional means either you can use, otherwise no need for use. That is called optional, but these are not a mandatory. Okay, now, but first normal, second normal, third normal, BCNF, these are very oftenly the people are using, and these are mandatory techniques when you want to implement your normalizations. Okay, now, so this is what we called as a total techniques of normalization. Okay, now, right? And the normalization topic is completed here, and this document also my people are sharing to you. Okay, so this normalization document will be shared to you. Okay, now, so right, and this normalization complete the concept where the people are using means in your designing levels. Okay, now, so whenever you want to develop an application, okay, so whenever you want to develop an application, before developing an application, they're going to be designed like a simple, you can say, use case diagrams. Like we are going to be preparing some use case diagrams. Okay, now, so in that designing patterns, these all techniques are using. That means complete normalization technique is using at a designing levels only, not implementation. Not implementation. These are only designing phase we called. Okay, now, right, guys. And yes, this complete document will be shared to you. And these are what now SQL topic or SQL language related course. These are. Okay, now, so these are all examples I was given. These are all are examples for you. So courses, opted table, hobby table, this is all every technique wise one example I was given, and these are the examples of your techniques, and these examples you have to prepare your own way. Yes or no? So as it is, you have to design these all tables in your database. That is called a normalization. Okay, now, so that's why every technique wise one real life example I was given for every technique. The fourth normal form, one example. Fifth normal form, one example. Like a boys code normal form, one example. Yes or no? These are what examples. Okay, na? So like what we can say, student table, whatever you can take. Okay, like second or third normal form, one example. Okay, so second normal form, one example. First normal form, one example. So these are all are the examples of your each and every technique wise I was given. So once you take it this one and read once the completed the information about normalization, so as it is table you have to design. That means you have to implement in your database. That's it. And today, whatever the tables are you created in your database, every table is called as a normalization form only we are preparing. That's why employee data we are storing under employees table. Departments data we are storing under department table. Student table data we are storing under student table. Course table means course table. So why are you separately storing? Tell me, why are you separately storing? So why not this all data? Why not we can't store into one table? Okay, so now in our database there are so many tables we design. Yes sir. There are so many tables are designed that every table whatever you designed in your databases, that is called a normalization tables. That is called as a normalization tables. Okay, now, so now we can go and check out every table, because normalization technique is what now we said, storing data into multiple tables, organizing data into multiple tables. So now suppose some example database. Now my database tables are there. Here, department table. So this is one normalization table example. EMP table. So department table, only department's data is stored. EMP table, I'm storing only EMP related information. Salary grade table, I'm storing only salary related information. So the question is, why sir are you creating three tables? And in three tables, why are you storing in three levels? Can I store this all are in one table now? Yes or no? So employee details, department details, salary grade details. These all three different tables data. Can I store into one table now? Then why are you creating like this? Why are you creating like this? Because we already said to you because when you store all different related data, when you store into one single table, then what is the problem? Duplicates are data redundancy problem is occurred. Memory is going to be occupied more, and insertion problem, updation problem, deletion problem. Yes or no? So these are the five problems we are facing when we store all types of data in one table. That means employee data, departments data, salary grade data. Yes or no? So these all are storing into one table, then we are getting a problem. What is a problem? The redundancy problem, occupied memory problem, insertion problem, updation problem, and deletion problem. So to overcome these problems purpose only, in every database you can see, okay, every database for each relation, but for each information storing purpose, one separate tables are designing by people. Yes or no? So now EMP is a one table. EMP is a one table. Okay, in that EMP data is stored. DEPT is a one table. In that department's data is stored. Salary grade one table. In that salary related information is stored. Like items one related information, items two related information. Yes or no? These are all are called what? Best examples of these are all are called as a normalization tables. These are all are called as a normalization tables. In the same to say MyDB 6 p.m. Here also we created. Okay, we are also create a course table. So course related information we are storing. Student table, student information we are storing. Registration table, register. But why is our student to course registration? These three tables data can I store into one table now? Yes or no? Can I store into one table now? But we can't store. Why? If you store these are all are in one table, then redundancy, occupied memory, insertion, updation, deletion problems are occurred. So that's why every related information storing into separate tables in our database. So these are all are examples of your normalizations. Okay now, so these are all are examples of normalization. So every table is a normalized table only we are designing or creating under databases. Okay now, so this is a concept of your normalization means don't think that okay what we want to do sir, what we want to do sir, nothing you want to do. Every table, that means every separate information are you storing into separate tables, then it is called as a normalization. Okay now, so don't think somebody very confusing. Normalization means, now simple I will tell you, normalization means what now? A related information, every related information store into every individual tables. So don't store into one table, store into multiple tables is known as a normalization. Okay, so like whatever we table designing, whatever the data we are storing, every table is called a normalization table. Okay, right. So this is what guys your normalization technique, and your SQL part is completed. And yeah, so tomorrow I will started my second part of SQL server, that is called as a TSQL language. Okay now, the second part we have started at what? TSQL. So this is part number 2 in our SQL server. So in TSQL, we are discussing some more concepts, which is related to transaction structure query language. Like in this language only, we are discussing like cursors, stored procedures, stored functions, triggers, exception handlings. So these are the topics that comes under TSQL. So in that we will be discussing that. Okay now, right guys? And that part we will be started tomorrow, as a freshly we started TSQL language, and we are discussing what is the differences between SQL and TSQL. SQL, which kind of things are not supported, and what kind of problems are there in SQL, and those problems how to overcome by using of TSQL language, TSQL language, how it was going to be, what kind of features are introduced in TSQL. So these are all kind of variations and differences we will discuss, and later TSQL programs, how to write. Okay, that all one by one we will be discuss. Okay, na? Right, guys. And I stop it here. And this normalization also my people are sharing to you in Google Classroom. So once take it, and after receiving, once read yourself and check it all examples. Okay, na? Right, guys. Thank you. Thank you so much.